Hello guys, welcome to this channel. This video is for you if you're writing IJMB or Jupeb examination, especially those that are writing physics, chemistry, biology, and mathematics. So we are going to be throwing videos based on these subjects, and then we solve questions based on the examination bodies, that means the past question. So endeavor to subscribe to this channel, and don't forget the channel is also for O-level engineering students or any science students from O-level up to the A-level. So endeavor to share to others and let them subscribe to the channel. They will get the best of our videos. So now this video is basically for Jupeb IJMB students, and here we are going to talk about the physics. So the IJMB and Jupeb syllabus is divided into four as far as the subjects I've mentioned are concerned. So but for this video we treat physics first, so and then we bring more videos on physics, so and all the other subjects too. So now for physics we are going to be having the four syllabus. So one of it is PHY 001. So you have PHY 001. So this particular one is called mechanics. So just like the branch of physics, mechanics. Okay. So then we have PHY 002. So and that one is optics and wave. Then we have PHY 003. That is electricity. And we have PHY 004, and that is actually modern physics. So we have various of topics under mechanics, we have various of topics under optics and wave, we have various of topics under electricity, and also the same thing applies to the modern physics. So we are going to treat all these topics just like the success of the exam is our priority, and that is the purpose of making this video. So we're going to start with PHY 001. So as any topic I might decide to treat might come from any of these two. So the syllabus of every one of them, I think maybe if time permits, I can make a video short where I show you all the topics under each of the syllabus. Okay. So but let's quickly pick PHY 001. So I'll talk about one of the topics. That's the first topic in PHY 001. Okay. So now let's move on. So we have in PHY 001 mechanics, we'll be talking about quantities and dimensional analysis. So we'll be talking about these quantities and dimensional analysis. This is not the first time as a physics student you hear about quantities. Quantities are parameters that are measurable. You can measure them like length, time, temperature. We have other parameters like areas, volume, and so on. They can all be measured. So in that wise, what is a quantity? That is a quantity, a parameter that could be measured. Now the quantities are divided into two. We have the fundamental and we have the derived. The fundamental quantities are quantities that does not depend on any other quantity. So and mostly you can calculate them using a device or instrument. You get just like mass. Mass is a fundamental quantity. I think you can measure with balances. You can measure with scale. Let me use this simple word. So then you can also have length. It could be measured using a meter rule, tape rule, or whatever instrument. So we have time, you can use clock to measure time. And we have temperature, I think thermometer, we measure temperature. So all these quantities, they are fundamental. Fundamental quantities are not really much. So then the derived are the ones that are much. And derived quantities, they are actually quantities that depends on the fundamental. In that wise, so like take for instance, we have area. Area is a derived quantities. So it is derived by multiplying two lengths together. So units of derived quantity is always gotten from the fundamental quantity. Take for instance, we have fundamental length. So and this is derived area. So area is same thing as length times breadth. So length is a length, breadth is a breadth. So the unit for length, which is the SI unit, is meter. So which means to get the unit for area is going to be meter times meter, and that will be meter squared. So this is a unit of the derived quantity gotten from what it is, what fundamental it composes. So anyway, all these are basic knowledge in physics that every student writing this exam would be able to understand. So directly I'll be moving into dimensional analysis. I don't want to dwell much on these quantities, so you can just try to brush up yourself with the little explanation I've made on it. So I think you should be able to recollect, even if it has taken a while for you that you've done the topic. So now let's quickly look at what dimensional analysis is. So the word dimension is just talking about writing a particular derived quantity in the component fundamental. So I said area is made up of length, and when you say length times breadth, okay, let me just put it this way. Some people might believe length is different from breadth. So now from here to here, let's call it length. So I will call this breadth. Okay. So if I will measure it, I will measure this as a longer length, this as a shorter length. So all are still length. So length is still length, breadth is still breadth. So they will have the same unit, meter, which is the SI unit. So by the time I multiply the two to find the area of this rectangle now, so I think I'll have meter squared. Okay. So dimension of area will now be the component fundamental. So we know that area is made up of two lengths. So we can write the dimension as L times L. So in that one, that will be L squared. So that's it. So this is just the dimension of area. So if we take it to volume, if we talk about volume is length times breadth times height. All these are still lengths. So which means we are multiplying three lengths together, so and that will be L cubed. So this is dimension. Okay, now we have been talking about quantities that are made up, that's just length is the component fundamental. Let's look at quantities that has mass or time in it, because all these are fundamental quantities. As Jupeb and IJMB students, you just need to understand how to write dimensions of quantity in terms of M, L, and T only. Anyway, there is still dimension of quantities in terms of I, which is current. I means current, and current is also a fundamental quantity. So writing a derived quantity in terms of the fundamental it is made of is what we call the dimension of that quantity. So we are just going to restrict ourselves to writing the dimension of quantities that consist of mass, length, and time alone. Okay. So now I will just give like two more examples and then discuss the use of dimension. So the basics of this dimensional analysis is that you must understand and know the formula to calculate a particular quantity. So take for instance, if I say speed. Speed is a derived quantity, and if you have to define speed, you say speed is the rate of change of distance with time. Okay, you can write the dimension of any quantity irrespective of whether it is a vector quantity or scalar. So now, speed is a scalar quantity, but it has the same dimension as velocity. So let me use the word velocity. So now, velocity is the rate of change of displacement with time. So which means displacement is still distance and time is t. So which means the velocity is made up of just length and time divided. So okay, we can say velocity is what? L over t. So this is the dimension. I can just simply write it as L t raised to the power minus 1. You know how we got this. So then this t under is coming up. So since it is under, it's going to carry a power of minus 1. So that is it. Just like law of indices. 1 over t times L. That's what it means. So then this t, 1 over t will become t raised to the power minus 1 times L. We have this. So that is dimension. You can write dimension of every other quantity as well. Okay? So you must learn the dimension of varieties of quantities, the fundamental. You can get that from source of textbooks. You get so you should know the formulas of a quantity and the dimension. So if I want to tell you the dimension of acceleration is equals to velocity over time. Now, this is now more complex because I don't have a direct fundamental here. I have an indirect fundamental because when I was talking about the dimension of velocity, I said it's distance over time. So we have two direct fundamental, that is length and time. But here we have indirect fundamental because I still have to write the dimension of velocity, which is also indirect, over time, which is a direct fundamental. So which means I'll be having the dimension of this L t raised to the power minus 1 all of the t. So that will give Lt raised to the power minus 2, just like this one comes up. So these are what you need. However, all these must have been taught at a level lower than this exam. So here we will be going into fully the dimensional analysis where we talk about the uses of dimension. The uses of dimension. What are the uses of dimension? What do we use dimension for? So what is the purpose of writing dimension? You may ask yourself, why do we write dimension? So we have just about 3 uses. So the third and the second one are interwoven, so they just have let's say a similar, but we just have to separate them just based on the type of question you're given. So but I will just summarize into 3 uses. So the first one is to check the correctness of a formula. So you use dimension to check the correctness of a formula. And secondly, to derive the dimension of a parameter in a formula. So which means if you have a formula and we have done something like this, number 2, because when I said derive the dimension of acceleration, just like I said, acceleration is velocity over time. So then we are deriving the dimension of acceleration, which is a parameter in this formula. So then we have to know the dimension of velocity and time and then derive that of acceleration. So it's typically what number 2 is talking about. Just that I am going to solve maybe one more complex question on this. Not really complex, but like not a simple formula as this. So we'll use that as a kind of error. So then the last one is to derive an expression or formula from statement. So a statement can be made by maybe take for instance, if I say the mass of a body depends on this, like I mentioned other parameters that the mass of the body depends on. So this is a statement. So in order to prove the statement right or probably get a mathematical interpretation of it and derive a formula, we can use dimensional analysis to do that. So these are the 3 main uses of dimension. So let's quickly go to the first one and solve a question on it. Okay. So for the first one, which is the uses of dimension, so I rename this 1, I'll name this 2 and 3. So I don't have to rewrite the whole word again. So probably I leave this part of the board so we can just make reference to it. So now, take for example, if I say find, okay, show that v squared equals u squared plus 2as is dimensionally correct. So there are different ways this question could come. It can come in form of check the homogeneity of this formula. Homogeneity is still the same thing as talking about the correctness of the formula. Okay, so now if you want to check this formula, how correct it is, you can use a dimensional analysis. So now let's go through the slide of this board. Alright, so we have v squared equals u squared plus 2as. So we want to check the correctness of this formula. So we must know the dimension of every parameter in this formula. That is just it. So this is a velocity. Okay, though I didn't tell you the parameters in this formula. V might be something else, but we are familiar with this. So V represents velocity. In most cases, they will tell you what the parameters in the formula is. So V is velocity and U is also velocity, representing initial, while V is representing the final velocity. Okay, then we have 2 is a constant, A is acceleration, S is actually distance. So 2 is a constant and it doesn't take part in dimension. So have that at the back of your mind. Constants do not take part in dimension. So now if I write the dimension of velocity, that's L t raised to the power -1 all raised to the power 2 equals, this is also velocity, L t raised to the power -1 all raised to the power 2 plus, what's the dimension for acceleration? That's 2 L t raised to the power -2 multiplied by L. Okay, I think I just have to show that this is left hand side and this is right hand side. So we just have to simplify both left hand side and right hand side and see if the dimension of both sides are the same. If the dimension of both sides are the same, that means the formula is dimensionally correct. So now, left hand side has a dimension of L squared t raised to the power -2. So now let's check out the right hand side. The right hand side has the dimension of L squared t raised to the power -2 plus 2L squared is this and this, and t raised to the power -2. So we have L squared L squared t raised to the power -2 plus 2L squared t raised to the power -2. I think that gives us 3L squared t raised to the power -2. So now let's check the left hand side with the right hand side. I mean, you might be having it at the back of your mind that they are not correct or they are not the same. No, 3 is not supposed to take part in dimension because it's a constant. So far the L squared t raised to the power -2 is the same with what we have here. So we can say therefore v squared equals u squared plus 2as is what? Dimensionally correct. So that is how to use dimension to check the correctness of the formula. So if you are given any formula, just try to know the parameters in the formula and try to write the dimension of the left hand side, dimension of the right hand side, simplify the both sides and see what the difference is. So even if you have a constant, be it fraction, decimal or whatever, so the constants do not take part in the dimension. So I think, so we're getting rid of the first use of dimension. So now, we have the second use of dimension. That is to derive the dimension of a parameter in a formula. So I've done that before, so I just want to solve one more complex question on it. So now, let's look at the second one. For the second part of it, I said that, okay, let's take for this example, so that's 2, so let this be 1. So now, take for instance, how we set the question in form of what problem? So the force of attraction F of between two masses M1 and M2 at distance r apart is given as F equals G M1 M2 over R squared. Okay, find the dimension of universal gravitational constant G So look at this question very well. So we said that the question can come in this form, like what problem? So the force of attraction F between two masses M1 and M2 at distance R apart. So I think the parameters, things that are in the parameter have been stated. So this is force, these are masses, and this is distance. So now you're able to find the constant, the dimension of the constant, so which is the only one you don't know. So in order to solve this kind of question, you have F equals G M1 M2 over R squared. So you must know the dimension of every other parameter. So force is mass times acceleration. I think acceleration has the dimension of this. So force is mass times acceleration. So I just have to multiply this with m. So dimension of force is going to be ml t raised to minus 2, all equals g. Mass and mass, irrespective of whether they are the same or different masses, we have the same dimension, mm, so that will be m squared. All over, this is distance, so that's l squared. So if you multiply both sides by l squared, in order to remove the l squared here, or let's just say, let this go, I have to multiply this. I think I have ml cubed, that's l squared times l, equals, then I'll be having gm squared. So then what we'll do next is to divide both sides by m squared. Okay, I think I omitted my t raised to minus 2. So then this goes with this. So what will be the dimension of g? It's going to be, this goes here, you're going to be having m raised to power minus 1, because you have m1, and by the time you cancel it here, you'll be having 1 m, so which will become m raised to power minus 1, then l cubed t raised to power minus 2. So this is the dimension of g, and we have actually found the dimension of the unknown. So that's good. So now that is the second use. So if you're given any formula, you can just try to find the dimension of that formula, of the parameter that is unknown from the known ones. So that is one of the use of dimension. So we go to the third use of dimension, which is to derive an expression or formula from a statement, and that will be the last part of this video, where we finish one topic in PHY 01. So now let's get rid of this. So then we move into what we call the 3. So now in 3, to derive an expression or formula from statements. So let's give one example of that. So take for example, it could come in any other form. Just make sure you know the parameters in the formula or in the statement, so you could write the dimension of those. Yes, you could write the dimension and derive what the formula should be. So if I tell you that so-so parameter depends on this, it might not be true. So one of the parameters might not depend, but by dimensional analysis, if they are actually connected, if the parameters are actually connected, we will know. Okay, let's take for example, if I say that the wavelength lambda of a particle depends on the mass m and velocity v of the particle. Okay, mass m, velocity v, and Planck's constant h. Planck's constant h. Okay, are you there? So now we just have to derive an expression from these statements. So this is something that I know myself, because I'm familiar with the formula that says wavelengths, okay, is equals to the Planck constant over mv. You get that? So we can use a dimensional analysis to prove that's right or wrong. So provided we know the dimensions of every other thing here. Are we there? So now, the statement says we want to check if we are going to derive this. Since that is what is given to us in the question, that wavelength depends on these, and this. So in order to do that, say wavelength depends on the mass, the velocity, and Planck's constant. So in that wise, I have wavelength equals k and v/h. Forget about the k that is not here, so it's constant. So we can neglect it. So take it out of it. So now we can start by, when you have this kind of question and v/h, all you need to do is raise all the quantity here to the power of any letter of your choice as a variable. So let's use a, b, c. Then you can start writing their dimensions. This is wavelength, so L. Mass is still m raised to power a. Velocity as a dimension of this, raised to power b. And Planck's constant as a dimension of m, L squared, c raised to power -1, or raised to power b. So that is the dimension for Planck's constant, in case you don't know. So now what next? After writing this, you have L equals m raised to power a. You just have to open the brackets, L raised to power b, c raised to power -b. And here you'll be having m raised to power b, and then you have L raised to power 2b, and then you have c raised to power -b. Okay? For like terms, so m with m, I think I will have m raised to power a plus b. That is using the law of indices. L with L, I think I'll be having okay, L with L, I think I will have L raised to power, that is 3b. If that is right, so L raised to power 3b. So then what next? I go with, okay, I use A, B, C, so this is supposed to be C, sorry. So I think I'll be having C here, and then C here. Okay, good to go. So the ones with B is just L raised to power B. Okay, so I think here is not supposed to be. We go again, so this is m raised to power a plus c by merging these two together. So then this L with this L, that is b plus 2c. Then I'll be having the t to be minus b minus c. So then there is m L at this side and t, so we can put m raised to power 0, t raised to power 0 at this side. We just have to do that so that we will have m here and m here, t here and t here, and L here, L here. So equating the m raised to power 0 equals m raised to power a plus c. So I think that will give us 0 equals a plus c. So that is the first statement, 1. So then equating the t raised to power 0 equals t raised to power minus b minus c. So I think this will give us 0 equals minus b minus c. So and that is 0 equals b plus c. So let's take this as 2. So we'll continue from this side of the board. So we can get rid of this now. So now, next is we equate the L. So that is L equals L raised to power b plus 2c. So that is 1 equals b plus 2c. So that will be 3. So we have 3 equations here. 0 equals a plus c, and that's 1. We have b plus c equals to 0, that's 2. So we can solve this simultaneously. In order to get this, so I can make b the set of formula. So from 3 now, so I think 1 equals b plus c plus 2c. So b will be what? 1 minus 2c. So then I put that here. So that is 1 minus 2c plus c equals to 0. So then that will give us 1 minus c equals 0. So c equals 1 from here. So what next? I've gotten b and c, so I can easily get a. So a plus c equals to 0. So if a plus c equals to 0, so and c is 1, so that's a plus 1 equals to 0. So a will be what? Minus 1. Okay, we have not gotten b actually. So if a is minus 1 and c is 1, we can easily get b. So b equals 1 minus 2 into bracket 1. So b will be what? 1 minus 2. And b will be what? Minus 1. So now therefore, a equals minus 1, b equals minus 1, and c equals 1. So what are we using them for? We have to rewrite our expression, which is here. We have to rewrite it. This equals n raised to the power a, b raised to the power b, and h raised to the power c. And put it. So that is n raised to the power minus 1, b raised to the power minus 1, and h raised to the power 1. So these ones will be 1 over n times 1 over v times h. So h times 1 times 1, I think that gives us h. N times v is nv. So we eventually got the formula we have here. So it means this expression or this statement is actually correct. So thanks for watching. Endeavor to subscribe to this channel and send the video to those who need it. And more videos will come on other subjects and more on physics as well. So just stay tuned. Thank you.